Okay, so what is then a radian? So we know what degrees are, so the question is, what is a radian? And we're going to begin with a circle. Center, radius, circumference. And unlike a degree, where actually our definition for degree is just how far have I turned, the definition for radian is actually reliant on the circumference as well as the radius. So what we do is, I'm actually going to set my radius to 1 at the moment to begin with, just to make our life a little bit easier. And here's what we do. It's very, very simple. Imagine you are standing right here and you are going to go for a walk around the outside of the circle, and there's somebody else standing in the center here and they are facing where you are. So as you walk around the outside of the circle, this person in the center is slowly rotating, so he's just turning to keep his eyes on you. Now, seems like a bit of a bizarre context, but this is our definition of a radian. If I have a radius right here of 1, and I walk a distance here of 1, now this is a unit circle, so if I walk a distance of 1 unit around the edge of this circle, then the person in the middle has turned 1 radian. And that's it. That's our definition of radians. Now the reason this is preferable for doing slightly more complicated maths is that what we've done is we've used the circle itself to define our measurement of angles. And the way we've done that is just by paying attention to the radius and the circumference and connecting those two ideas up. So if I were to walk 2 units in length, I'd kind of be here-ish, and I'd have walked 2 radians. Now that gives rise to a few kind of important questions. First of all, what if me standing in the center and you walking around the edge, you force me by walking all the way around a full semicircle, you force me to turn around and face the other way. Question is, how many radians is that? Well, this was a unit circle. So actually the real question we're asking is, what is the arc length on that semicircle? How long is that curved line? Well, we know that circumference is 2 times pi times the radius. Well, that's a semicircle, so actually I want to divide them by 2. So my arc length is 2 pi r divided by 2. Also the 2's cancel, so it's pi r, but r is 1, so it's pi. So if I were to turn a half turn, I would be turning through pi radians. And in exactly the same way, a full turn, well, that's the full circle, I don't have to halve it. So I would have turned through 2 pi radians. So I now have a full circle 360 degrees is the same thing as turning through 2 pi radians. A half circle, 180 degrees, well, that's the same thing as just turning through pi radians. Now this works at the moment with the unit circle because we're walking around these lengths, but actually circles scale up very easily. So if I were to change this from a unit circle to, say, that length was 10, and that length was 10, I'd have walked the same exact angle. I would have turned through the same angle. It would scale up nicely. So actually, this works with any circle, not just the unit circle. And what we're doing is, the radians are the ratio of the arc length to the radius. So if I walk 10 units and the radius is 10 units, my ratio is 1, I've got 1 radian. If I walk pi units and my radius is 1, then I've walked pi radians, and in fact that's the semicircle. If I decide to walk 2.5 times the length of my radius, so my radius is here, and I walk around kind of 2.5 times, so I'm here-ish, so this is 2.5 r, this will be 2.5 radians. It is the ratio of those two things, and it doesn't actually matter what the radius is. This length and this ratio will give us the same angle, the same turning every single time. So our definition for a radian now is not to do with some arbitrary choice in turning 360 is nice and divisible, but it is the ratio of how far have I walked versus what's the radius of my circle. Okay, it's a much more precise mathematical definition for measuring angles, and it gives rise to some extremely useful things. Now let's just have a quick look at the textbook page on this. So it talks about a bunch of stuff. You've probably only measured angles in degrees. That's probably true. 1 degree is 1/360th of a complete revolution of a circle. So we've got some quite technical language going on in here, but it's very straightforward. But we can also measure using angles called radians, and then we have this very formal sentence here. 1 radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Gosh, so that sounds really complicated. This word subtended, a good synonym for that would be formed. So it's the angle formed at the center of a circle. So I've got a circle, I start here, there's my radius. If I walk around by the radius, I form an angle, and that angle is 1 radian, just like the diagram we looked at earlier. Okay, and then we've got a little, again, a slightly more formal diagram and definition. If arc AB has length r, then the angle AOB is 1 radian. If the arc length is equal to the radius, then the angle is 1 radian. Done. In the same way, the circumference of a full circle is an arc length of 2 pi r, so it subtends, remember that means forms, an angle of 2 pi radians at the centre of the circle, so 2 pi is 360, which consequently means pi is half a circle. And another little consequence of that is, if pi radians is 180, I can divide both sides by pi, and I get 1 radian is 180 degrees divided by pi. Now that's 57.9 something, I think, off the top of my head. It's not a neat number, it's not a special number. It's not special or neat because remember that 360 is completely arbitrary choice for our measurement of angles. So there's no reason that it would be connected in any special way to radians. There's no reason that 1 radian would be a special nice number of degrees. It isn't, because degrees is just a choice made for convenience, whereas radians is built out of the properties of circles. So that's what a radian is. It's just another way of measuring angle, but it's a way that's grounded in some more concrete mathematics, and that gives us access to a whole lot of other stuff, some of which is just a bit easier in radians, and some of which is impossible if you're not using radians. And so we're going to start looking at some examples of how to switch in and out of radians and degrees, how to think more clearly in radians, and then we'll move on to what are they actually useful for, what maths can we do that is much, much simpler in radians versus degrees.